Welcome to today's tutorials. We are working on section B of IJMB 2016. Please get your writing materials ready and your calculators. Will be right back. Prove by mathematical induction that 1 squared plus 2 squared, 1 cube plus 2 cube plus 3 cube plus plus n cube equals to n squared bracket n minus n plus 1 squared all over 4. Now, mathematical induction simply helps us to prove that a statement is correct or true. Now, looking at our base case where n equals to 1. Now, imputing 1 into this becomes n squared bracket n plus 1 all squared all over 4. Substituting 1 where we have n will become 1 squared bracket 1 plus 1 all squared all over 4. This will give us 1 bracket 2 squared over 4, which is 1 times 4 over 4, which is 1. Now, this proves that for the value of n equals to 1, that this statement is true. Now, for the second part, where we have 4n raised to power 2n minus 1 is a multiple of 5. Now, what are multiples of 5? Multiples of 5 are numbers that 5 can divide easily without a remainder, like 10, like 15, like 20, 25. All those are multiples of 5. Now, let's see. Using our base case also, where n equals to 1, this becomes 4 squared n minus 1 equals to 4 raised to power 2 bracket 1 minus 1. This will give us 4 raised to power 2 minus 1. 4 raised to power 2 is 16 minus 1, which will give us 15. And 15 is a multiple of 5. So for each of these cases, we can see that by mathematical induction, we have proved that these cases are true. The polynomial px cubed plus 3x squared plus 3x plus q has a remainder. Our remainder as 19x minus 11, and is divided by divided by x squared minus 3x plus 2. Find the values of p and q. With these values of p and q, factorize the polynomial into linear factor. Now, for us to get the values of p and q, let's factorize this to get the factors of this. So if we factorize this, we're having x squared minus 3x plus 2, which will give us 2x squared. And we know that the factors of 2x are 2 and 1. But since this is a negative 3, both will become negative. So this will become x squared minus 2x minus 1x plus 2. Grouping them, we are having x squared x bracket x minus 2, and this will become minus 1 bracket x minus 2. So our factors become x minus 1, x minus 2. So therefore, x equals to 1 and x equals to 2. Now, from here, we are going to substitute the values of x when it is 1 and 2 into this equation. So we are having p when x, let's say when x equals to 1. So p bracket 1 cube plus 3 bracket 1 squared plus 3 bracket 1 plus q. So this will give us equals to 19 bracket 1 minus 11, since that's our remainder. Okay, now this will give us P plus 3 plus 3 plus Q equals to 19 minus 11. Alright, this will give us P plus 6 plus Q equals to 19 minus 11 will give us 8. So P plus Q equals to 8 minus 6. So P plus Q equals to 2. Let's call this equation 1. So when x equals to 2, we have P bracket 2 cube plus 3 bracket 2 square plus 3 bracket 2 plus Q equals to 19 bracket 2 minus 11. Now this will become 2 raised to power 3 will give us 8p plus 2 raised to power 2 is 4. 4 times 3 will give us 12 plus 2 times 3 will give us 6 plus Q equals to 19 times 2 will give us 38 minus 11. Now collecting our terms, we have 8p plus 18 plus Q equals to 8 minus 1, 7, 3 minus 1, 2. So this will give us 8p plus Q equals to 27 minus 18. And 27 minus 18 will give us 8p plus Q equals to 9. Equation 2. Now substituting, equating our two equations, we have 8p plus Q equals to 9 minus our equation 1 and 2. That will become P plus Q equals to 2. Now we are subtracting equation 1 from equation 2. Now this will become 9, and Q minus Q will cancel out. 8p minus P will give us 7p equals to 9 minus 2 will give us 7. So therefore, P equals to 7 over 7, which is 1. So the value of our P is 1. Now substituting into equation 1, where we have P plus Q equals 2. Since P is 1, this becomes 1 plus Q equals 2. So therefore, Q equals 2 minus 1, which will give us 1. So the value of P and Q are both 1. Now back to from our equation that we have P x cubed plus 3x squared plus 3x plus Q. Okay, now from here we can see that the value of P is 1. So this become, our equation will become 3x cubed plus 3x squared plus 3x plus 1. It's our equation. Now, they said we should factorize this equation to give us a linear equation. But now, we know that mathematically, if we should do this, our answer should give us x minus x plus 1 raised to power 3. Alright, I'm going to go ahead to expand this to see if we would actually get this as a proof. Now, if we're having x plus 1, x plus 1, x plus 1. Now, let's do this 2 first. This will give us x times x. It will give us x squared. X times 1 plus x plus 1. X plus 1. Now, doing this, collecting like times here will give us x squared plus 2x plus 1 against x plus 1. So you have x squared plus 2x plus 1 times x plus 1. So this becomes x times x will give us x cubed. This x times 1 will give us plus x squared. This times this will give us plus 2x squared. This times, we've done this times this, x cubed. This times this, x squared. This times this, 2x squared, plus this times this will give us 2x plus x plus 1. So collecting terms together, we have x cubed plus 3x squared plus 3x plus 1. So this brings us back to our original equation. So the linear factors of this will become x plus 1 cubed. Solve the inequality. We have x minus 1, x plus 3, all over x plus 2, 0. Now, in solving this, we are first going to multiply x plus 2 to both sides. So we have x plus 1, x minus 1, x plus 3, all over x plus 2 times x plus 2, 0 times x plus 2. So this we cancel this, leaving us with x minus 1, x plus 3 equals to 0. Now expanding this, we are having x squared plus 3x minus x minus 3. So this becomes x squared plus 2x minus 3 equals to 0. Now we factorize our x squared plus 2x minus 3. If we find the factors of this becomes minus 3x squared. Now our factors become 3 and 1. But since one is negative, the other is positive, we have to find one of our factors which will be negative. But since our middle factor is positive, then our smaller factor will become negative. So this becomes x squared plus 3x minus 1x minus 3, 0. Now, so factorizing these two, we are having x is common, x plus 3, and minus 1 is common, we are having x plus 3. So this will become x minus 1, x plus 3. Now equating all to 0 becomes x minus 1 is greater than or equals to 0, and x plus 3 is greater than or equals to 0. So therefore, x is greater than or equals to 1, and x is greater than or equals to minus 3. So these are the root. We have solved the inequality to be this. If the roots of the quadratic equation 6x squared plus ax minus b equals to 0 are alpha and beta roots, its roots are alpha and beta. Obtain the quadratic equation whose roots are, let's call this our new roots, equals to alpha squared over beta and beta squared over alpha. Alright, in doing this, let's keep in mind that our alpha plus beta equals to minus b over a, which is going to be here. In this case, our b is c, is a minus a all over our a is c, while our alpha beta is c over a, which is going to be 1 which is going to be B over A. All right, for our new roots, we have alpha squared over beta and beta squared over alpha. So sum of roots equals to alpha squared over beta plus beta squared over alpha. Here, our LCM will become alpha beta all over, this will give us alpha cube plus beta cube. That's for our sum of roots. Then for our product of roots, we are having alpha squared all over beta times beta squared all over alpha. So this will give us, this cancel this will give us alpha, this cancel this will give us beta. That's our product of roots. Now, if we expand our sum of roots, so expanding our sum of roots, this becomes alpha cube plus beta cube all over alpha beta, which is going to give us alpha plus beta all cube minus 3 alpha beta brackets alpha plus beta all over alpha beta. But recall that our alpha beta is equals to minus B over C, and alpha plus beta equals to minus A over C. Now, substituting these values into this, we are having our x squared minus sum of roots x plus product of roots. Okay, now let's keep this in mind, for we'll be using it after substituting these values here. So back to our sum of roots. What will our sum of roots be? Our sum of roots will become alpha beta is minus B over C cube. Okay, sorry, alpha plus beta is minus A over C cube minus 3 alpha beta minus B over C against minus A over C. Now, all over minus B over C. All right, expanding this, we're having A cube all over C cube minus A cube over C cube minus 3 B times A will give us AB all over C times C will give us C squared all over minus B over C. Now, if we do this, we are going to have our LCM here is C, that's C cube. This will be minus AC squared, AC minus 3ABC all over minus B over C. So this will give us minus AC minus 3ABC all over C cube times C over minus B. So this cancels here, leaving us with minus AC minus 3ABC all over minus B C squared. So here, if we multiply through by a negative, we are having AC plus 3ABC all over BC squared. This is our sum of roots. Now, looking at our product of roots, which is product of roots, which is alpha beta, which is giving us minus b all over c. All right, now back to this equation where we have x squared minus sum of roots, which is giving us our AC minus 3ABC all over BC squared plus our sum of product of root, which is minus B over C equals to 0. Now expanding this, we're having x squared plus AC plus 3ABC all over BC squared plus minus B over C equals to 0. So multiplying through by BC squared, we're having x squared, all right, BC squared x squared plus AC plus 3ABC all over BC times BC squared minus B over C times BC squared. So this will give us BC squared x squared plus AC plus 3ABC minus B squared C. So this equals to 0. So this will be our new equation. Thank you for watching. See you in our next class. Ensure you subscribe. Click on the notification button to get more updates.